Yes, ma'am.
Yes. So under which did we study this barium chloride? Okay, we studied it under the limit test for sulfates, right? To confirm whether the sulfates is present within the limit or not, we use this barium chloride reagent, right? Which is also now replaced and called as barium sulfate reagent, right? We did go through it, right? So this is confirmed with the addition of some barium chloride to the filtrate. So what happens is, if in the filtrate any sulfate ion is present, then you will get a precipitate of your barium sulfate. If there is no precipitate which you will get, then you will say that the sulfate is absent. Okay. So this is how you're going to purify and confirm whether aluminium hydroxide you have got it in a pure form or not. So coming to the properties. So it is a white viscous suspension as we saw, okay, and it gives astringent aluminium chloride when it reacts with gastric hydrochloric acid. So you can see AlOH3 thrice, that is the aluminium hydroxide, reacts with your hydrochloric acid to give you aluminium chloride, AlCl3, along with your water, okay. This is a popular antacid and brings about neutralization. We already saw this reactions, how it brings about the neutralization. Remember this aluminium chloride, okay? Why I told you to remember is, you can see, we already saw also that aluminium containing antacids is constipating in nature. Now, why is it constipating? It is because of this aluminium chloride, okay? So when it reacts with HCl, it forms aluminium chloride, okay? This aluminium chloride is the one which causes your constipation, okay? So if anyone asks you why is aluminium hydroxide gel, constipating in nature, then you should say because it reacts with hydrochloric acid to give you aluminium chloride. This aluminium chloride is constipating in nature. This is what causes the constipation. Okay. So you may be asked this in your Viva. Coming to the identification tests. A solution in hydrochloric acid gives reactions which are characteristic of aluminium. So when an equal volume of gel is diluted with distilled water, the pH of the solution should not be more than 7.5. Okay. Coming to the test for purity, it has to be tested for alkalinity, ammonium salts, arsenic, chloride, sulfate, and acid consuming capacity. Okay, this acid consuming capacity is one different test itself altogether. Okay, so to confirm its purity, it should be checked for all this. So what is the test for chlorides? Okay, the test for chlorides, it is carried out by dissolving 0.5 grams of gel in 5 ml of dilute HCl, okay, followed by boiling and cooling and diluting the solution to 100 ml with water. After this, you're going to take 25 ml of the diluted solution and you're going to carry out the limit test for chloride. So we all know, right, limit test for chlorides, there is a standard and there is a test, right? The standard or the sample. So under standard, you will carry out the same thing for limit test for chlorides. Under sample, they will tell you, right, take 25 ml of sample solution. This is how you're going to prepare the sample solution if you're going to test the chlorides in your aluminium hydroxide gel. What you're going to do, 0.5 grams of gel, you're going to dissolve it in 5 ml of dilute HCl. You're going to boil it, cool it, and further you're going to dilute it to 100 ml. From this 100 ml, you're going to take 25 ml. So this 25 ml you will use for your limit test for chloride. The same way IP will have how to prepare the solutions for different kinds of preparation, and we have to follow it according to the pharmacopoeia itself. We should not just come up with something on our own. We have to follow what is prescribed. So same way, limit test for sulfate. So this is carried out by dissolving 5 grams of gel. For chloride, it was 0.5 gram. Here it is 5 grams of gel in 5 ml of dilute nitric acid. Okay, then you're going to heat it. The solution is diluted after cooling with 200 ml of water. It is mixed, filtered if necessary. So from this, you're going to take only 10 ml and you're going to add 2 ml of HCl. After you have done this, you're going to use it for the limit test for sulfate. Okay, so this is how you're going to prepare the sample solutions for testing for chlorides and sulfates by limit test. Next, coming to the assay, we'll just finish off this aluminium hydroxide, then we'll continue the rest of the compounds in the next class. So coming to the assay, an accurately weighed amount of sample is dissolved in a mixture of hydrochloric acid and water by warming on a water bath. 20 ml solution is taken in a conical flask and 40 ml of 0.05 normal disodium edetate is added to it, followed by water and few drops of methyl red. To this solution, one normal NaOH solution is added to neutralize. Okay, and this can be identified by the color change from red to yellow. After this, the flask is warmed on a water bath for half an hour. Then to this, you're going to add 3 grams of hexamine and 0.5 ml of xylenol orange solution. Now this xylenol orange solution is the indicator here. Once you have added all this, it is titrated with 0.05 molar lead nitrate solution until a violet color appears at the end point, which is due to the formation of your lead xylenol orange complex. Okay, so this is the assay of your aluminium hydroxide gel. Okay, so first you're going to dissolve in a mixture of HCl and water. 20 ml of this you're going to take, and to this you're going to add 40 ml of disodium edetate, followed by water and your methyl red indicator. After this, you're going to add one normal NaOH solution until it is neutralized, and this neutralization you can come to know from the color change from red to yellow. Okay, that is why you're adding methyl red there, so that your solution will become red in color. And once you add NaOH, as soon as it becomes yellow, that means to say that you have neutralized the solution. After this, you're going to warm it on a water bath for 30 minutes. Then you're going to add 3 grams of hexamine, 0.5 ml of xylenol orange solution. Now this xylenol orange solution is the indicator for titration. Okay, methyl red is the indicator for neutralization, whereas xylenol orange solution is the indicator for your titration. So what is it titrated against? It is titrated against 0.05 molar lead nitrate solution until a violet color appears at the end point. This violet color is due to the formation of your lead xylenol orange complex. So this is the assay of your aluminium hydroxide gel. Coming to the uses, it is a very effective antacid, but it is a slowly acting antacid. Okay, it does not get absorbed in the alimentary canal and does not produce carbon dioxide. Okay, now this carbon dioxide we saw right under systemic and non-systemic also, we saw that carbon dioxide is produced, but the advantage of this aluminium hydroxide gel is it does not get absorbed and it does not produce carbon dioxide. Next use is it is used in the treatment of intestinal toxemia and hyperchlorhydria. Next, it does not cause systemic alkalosis, which you can say it is not as a use, but you can say more of that it is an advantage when it comes over your sodium bicarbonate. Coming to the storage, it is stored in well closed containers and it should not be allowed to freeze. And for attractiveness, it is usually dispensed in blue or amber colored bottles. So this is the storage of your aluminium hydroxide gel. Coming to the last slide for today's class. First we look at the dose. So the dose is usually 7.5 ml to 15 ml. Okay, and since it causes constipation, it is administered along with magnesium salt preparations. So now this magnesium salt preparations has a laxative action. So to counteract or to balance it, you're going to always prescribe aluminum containing antacids with your magnesium salt. Okay, so that is what is called as combination antacids. Okay, the last topic for today is test for acid consuming capacity. That is how much of acid is consumed. One second. Are you still able to see the screen?
Yes, ma'am.
Yes, ma'am.
Okay. Test for acid consuming capacity. So an accurately weighed quantity of gel, that is 1.5 ml, is taken in a conical flask. To this, you're going to add 50 ml of 0.1 normal HCl. The contents are shaken at 37 degrees centigrade for 1 hour. After this, it is titrated for excess HCl with 0.1 normal NaOH using bromophenol blue as an indicator. Now, this is a simple acid-base reaction, okay? Acid-base titration. So, you're just going to take the gel. To this, you're going to add your acid. That is your 0.1 normal HCl. You're going to shake it for 1 hour and then you're going to titrate it against a base. So the base here is 0.1 normal NaOH. Indicator which you're using here is your bromophenol blue indicator. So depending upon what reading you get, you're going to say that this much of acid was consumed by the base or by the gel. So this whole thing is called as test for acid consuming capacity. Okay. So this is in general for all the antacids. Okay, it is not just for your aluminum hydroxide gel. So with this we finish aluminum hydroxide gel and sodium bicarbonate. We will see the rest of the compounds in the next class.